So what we're going to do now is we're going to talk about yet a few other examples in the RxJava Observable. And we're going to, once again, use these capabilities to asynchronously do operations on BigFraction objects. What we're going to do here is we're actually going to multiply BigFraction objects and then sum up the results. And this is a method that's called test fraction multiplications 2. It's also in the observable ex.java file in my ex3 folder in my GitHub account. And the particular thing we're going to show here is the reduce method. And we're also going to show the use of the flatMap concurrency idiom, which is important to understand if you want to get assignment number 4 to work properly. And then we're also going to illustrate yet another method, this time from something called the class maybe, and it's called do on success. And you'll see why we do that as well. So let's start off by talking about reduce. So reduce is an operation in RxJava that returns a maybe. We'll talk about what a maybe is in a minute. And this is going to apply an accumulator function to the first item emitted by the current observable. And the result of that accumulator function is then fed together with the next element emitted by the observable into the same function. So what we're basically doing here is we're going to be doing basically pairwise operations on elements that are in our stream of values that are being emitted by the observable. And this pairwise evaluation will continue until all the items have been emitted by the current and by necessity finite observable. What you get as a result is a final result, which is going to be provided as a maybe. So what is a maybe? Well, a maybe is essentially a variant of single that may contain no elements whatsoever. And the reason we need this is if we have an observable that emits no items in a finite amount of time, of course, then we are not going to have any results whatsoever. So that's why it's a maybe, because there may be no items. So if the observable that we're reducing has 0 elements in it or emits no values, then the maybe will not be successful. This operation, in order for reduce to work, it requires the upstream of the chain of methods, the pipeline in the observable chain, to signal the onComplete method before the accumulator object can actually be emitted. And if you have an infinite source that never complete, then nothing ever happens, and you'll probably get an out of memory error because it'll never reach a point where it's done. It'll just kind of loop infinitely. There's a reduce operation in Project Reactor's Flux class that works pretty much the same. And the streams reduce method is also similar, although oddly enough, unlike both Project Reactor and RxJava, you can give an initial value to the reduce method in streams. And if there are no items in the streams, that's the value that's used as the result from this. Whereas what you get with something like RxJava's reduce is this maybe, which is a little bit weirder in some ways. So we'll show how you use reduce here in a second. Then we also have flatMap. And flatMap, as we've talked about a number of times, can be used when each item emitted by a stream needs to have its own threading operations applied to it, or own threading operators applied to it. And this is what is colloquially referred to as the flatMap concurrency idiom. And you can read about that idiom at the link down below. So what happens here is we're going to go ahead and use the flatMap concurrency idiom for this example to essentially perform fraction multiplication in different threads in the computation thread pool. And so you'll see in a second when we look at the code in more detail how this works. So let's go ahead and take a look at the code and you'll see how this all comes together. To showcase the flatMap concurrency idiom, we're going to look at the test fraction multiplications 2 method. And this will also illustrate some other interesting semantics that you may or may not be aware of. And it's a little confusing at first, and I understood it a little bit, but it wasn't until I got a question from one of the students in office hours last week or 2 weeks ago when we met that really all the pieces came together. So I'll explain some things that may help you understand how to do this assignment correctly for assignment 4, and you'll also understand why you get some somewhat mysterious messages from the unit test if you don't do things in just the right way. So first, let's take a look at what we're going to have. We're going to have ourselves a list of big fractions, and we use the list of factory method to make ourselves a list of big fractions with the following numerators and denominators. So that's just basically predefined. Then we're also going to define ourselves a function called multiply big fractions. And you can see what this does is it's going to multiply the given big fraction by some constant, and then it prints out some diagnostics so we can see what's going on and returns the results. We also have another local variable. This time it's a consumer object, and it's called display results. And as the name implies, it goes ahead and appends the sum of the big fractions that are passed in and displays the whole kit and caboodle. Okay, so here's the main part of the function, the test fraction multiplications 2 method. And this demonstrates the RxJava flatMap concurrency idiom very nicely and very cleanly. And this will help us understand why we need to do it in a certain way. So what we're going to do here is we're going to start by taking our list of big fractions, and we're going to go ahead and convert it into an observable stream of big fractions. So we do that by using the from iterable method. So we've looked at from iterable before. From iterable is a little bit like stream in the sense that it takes something that's an iterable and converts it into an observable. We then take each of the big fractions that are being emitted by this sort of source observable, and we're going to run them through a bunch of transforms. And the first transform is flatMap, and this is where the concurrency idiom comes in. So the way to look at this is you say, for each big fraction in the stream of emitted big fractions from the observable, do the following. And this is where the flatMap concurrency idiom comes in. And this is very idiomatic, and I'll explain it as I go through. So the first thing we do is we say, take the big fraction here and just emit it. And you'll notice if you take a look around on the internet, you'll find that almost every use of just is really, really simple. In fact, you very rarely, if ever, or you really never should do kind of long-running operations in just. And the reason for that is just is always emitted in the context of the so-called assembly time thread. So there's two different kinds of times that are important in RxJava. You have what's called assembly time, which is when this chain is actually built up, and that'll run in whatever the calling thread is. In this case, it's the main thread. And then you have what's called subscribe time, and that could actually run in a different thread. And in particular, in this case, as you'll see, we're going to have other threads going on. So observable.just just emits that big fraction, does not do any long-running computations whatsoever. We then use subscribe on, and what subscribe on says is run the following code in a background thread from the computations pool. Now, normally, subscribe on also goes up to the beginning where the emission started. But in this case, because we're using just is always run in the assembly time thread. So even if we say subscribe on here, this just call is not going to run in the thread in the computation pool. It'll run in the assembly time thread. So what that says is you don't want to do any long running operations here because they're going to run in the assembly time context, not in the computation pool here. And that's a really weird semantic. And so some people ran into this when they were doing assignment 4 because they were doing some blocking operations in the context of just, and the unit tests were yelling at them. And the reason the unit tests are yelling at them is because you're not supposed to do long-running computations in just, because those don't get run in the designated scheduler, even when using subscribe on. And yes, those are crazy semantics, but that's just the wonderful quirkiness of RxJava. So the basic point of this is keep your just actions very pithy, very concise, and not blocking. In this particular case, what we're doing here is we're going to call the map operation. So for this particular big fraction, we're going to run the multiply big fractions object, local variable, if you will. That's going to be run in the computation background thread. And so the way to look at this is for every big fraction, then each of those things will be scheduled to run in a thread pool from the computation thread pool, in a thread from the computation thread pool. And so that's the idiom. And I would be the first to admit it's very idiomatic. You really have to understand what's going on under the hood to make any sense whatsoever of why this code is doing what it's supposed to be doing. And what it's doing is it's running each of those computations in a background thread in the computations thread pool. So for each big fraction, it's going to schedule that big fraction to be reduced and multiplied, or rather multiplied in this case, in a background thread in the computation pool. So you just have to get used to that particular idiom. It's very convoluted, but that's the way it works. So after all these computations finish, then we're going to have the reduce method get called. And what reduce is going to do is for each of the multiplied big fractions in the background, we're going to go ahead and add them together. So all these things get added up. And what we end up with as a result of this, as you can see, is a maybe. And the reason it's a maybe is because there might have been no emitted big fractions at all. Now, in this particular case, of course, there were a bunch of emitted big fractions because we gave 4 of them up here. But the reduce call doesn't know that. It just says, well, I'm going to reduce whatever comes my way until something is uncompleted and we wrap up. So we get back a maybe. And what we do here is we say, essentially, if there were, in fact, any elements that came through that we reduced, so we're going to end up with a single result here that will either have nothing in it if the observable stream was empty, or one element that's a maybe. So if there was something, then we're going to call the display results local variable, which in this case is going to go ahead and cause the results to be printed. And that's what's going to happen if, in fact, reduced succeeded because there were elements to be reduced. Clear as mud, of course, here. And then the final thing we do is we return ignore element because we have a maybe, and that's what's used to interface with the async tester framework, which is going to coordinate all this stuff and make sure it doesn't have the main program exit before all the computations are done. So if we go back over here and we take a look at what happened when we ran this computation, this is the result that came out of test fraction multiplications 2. So you can see that we had those 4 big fractions, and we went ahead and reduced them because they started out being reduced. So we had 33 1/3 times 4 1/2 equals 150, blah, 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 blah. And then what we do here is we go ahead and sum all these big fractions together. We sum up all these results, and we end up with 1,875 over 2. That's the result of adding up all those big fractions after we got done multiplying them. And you'll also notice that even though test fractions multiplication takes place ahead of test fractions multiplication 1 takes place ahead of test fractions multiplications 2, that this computation is much faster than these computations. So that finished first. And if we want to see, just to prove to ourselves, this is in fact what happens. If you take a look at the main program, the driver program, you can see that test fraction multiplications 1 gets done before test fraction multiplications 2, or sorry, it's invoked before, in that order, 1 followed by 2, but it finishes 2 followed by 1. And that again is just demonstrating the inherent non-determinism of the asynchronous processing that you would find in a framework like RxJava. And that again illustrates why we need the async tester framework, because we want to let all these things run in whatever order they run in. And then when they're all finished, then and only then will the main program go ahead and shut down. So hopefully this will make it a little bit more clear what you need to do for assignment number 4 in order to implement the, I think it's called get images on page method. And that method that you'll do for assignment number 4 has got to have the use of the flatMap concurrency idiom. And the new unit tests that should all be in your workspaces, if you've been keeping up with the class, should in fact do these kinds of evaluations on your code. So at this point, you should be in very good shape to wrap up assignment number 4, but it's a little subtle. And so if you have any questions, as always, please don't hesitate to ask and or come to office hours.